Now, yesterday I've told that there are steam generators or boilers, can have some classification according to their method of use. What is that? Some of them are defined or known as utility steam boilers or steam generators. Some are industrial steam generators and some are marine steam generators. What is the difference between these two? Or essentially they are same. That is the question. Question answer is difference is their applications and nothing else. They are same boilers, same turbines, condensers, everything is there, but only the application and according to the application, capacity is also different. Capacity matlab how much steam they are generating, rate of production of steam, and how much pressure under which they are operating, and what is the maximum temperature which is being built inside this boiler of this type of generators. So utility generators as defined are generally classified and used by the utilities of electric power generating plant. Whatever the powers we are getting having in our home, in college, and in our industries itself, they are being made from utility steam generating process. Now, it is
So which chapter is this, sir? This is my first class, sir.
low.
I'm not
As
in
per your as
introduction.
per your syllabus, there is the introduction, which is the basics of
Introduction.
everything like say boiler, some turbine, some condenser, etc., etc. But all of them are
Is this
very
the introduction,
detailed.
sir, or the chapter?
I will give you the handout notes after I finish. These are the first chapter, and this chapter is made by myself. It is not available in
Achha,
that case in the book because I have gathered the information in from different chapters, different books. You see, in your syllabus, these chapters, this is given as the introductory portion, tell you something about the all the constituents of the boiler or a power plant generating units. But it is not the finish because all of them has much more elaborate demonstration and application. So I'll tell you steam generator only say 1 or 2 pages. Okay, but steam generator will cover in your syllabus at least 20-25 pages minimum of this foolscap paper. Minimum I'm telling because it will be increase more. Like this, it is the extremely descriptive syllabus which you have. Among them, I have to find out the important one which is being used every time.
sir,
I am not
sir,
saying the
kindly
others are
give.
important. Others are not important, but it's covered by 1,000 pages of a book, 1,000, 1,200 pages of different books like this. Subject is fairly easy, but fairly descriptive. Okay, what
Okay.
is given here? What are the different type of boilers? Only that's all. And each boiler has at least a few 10, 15 pages matter left there, which we have to study. I am just giving you what is meant by the utility steam boiler. Now,
Sir, I just want to know the brief syllabus, syllabus in brief. What are the topics we have to study in this subject?
you want to know, want me to give you syllabus? Is it not available
Yes,
with
sir.
you?
So brief
Topics,
syllabus, sir, is
just
in
one
brief,
second.
sir. Matlab topic.
Okay, okay, I am answering your
What are
question.
the important?
I am answering your question then.
Since no one has joined, sir, so it's not interesting to study. So please give me the topics I can
Hmm. Just one
make
second.
my matlab.
Tell you. Hours. Right there. went out. Inside power, can't show all the images. Is it visible? I don't think so.
Yes, sir.
Hmm? It's not sharing. It is not kindly the sharing page. I think it is too big. Too much the matter is in open in the share. Huh? So you have to reduce a few of them. What's going on? Is it visible now?
Yes, sir.
Now, what is the definition? What is power energy? Okay, source of energy.
Yes,
All these thermodynamic cycles, these are already covered, related to power plant, fuel combustion, steam generators, steam turbines, and water turbines. This is the introductory
okay,
part
sir.
of steam turbine or boiler, condenser, water turbine, etc. Next class is what is the variable load? How you what is variable load? How you tackle them in the industry? Next time, total steel power plant. You see, all of them are available here. Almost it started everything about the boilers. Next it comes the diesel power unit. Next comes
Mm.
gas turbine power plant like this.
Yes, sir.
It's all the details and everything is fairly exhaustive. Things are
Okay.
and your chapter will be finished with
So some notes, sir, it's notes uploaded on LMS portal.
what you want.
Sir, sir, I just want to know that are the notes available on LMS portal or not?
Yes, it will be available, but after I finish one of the chapters, say if the class is complete, I think another class is required to finish this chapter, and I will send it the LMS to there. If not, still I will send it before your exam answers. Okay,
Okay, sir.
but that is not saying that it is the
So
final.
please,
If you like, you can read
so
more.
please send it like the chapter wise.
Definitely, not exactly chapter wise, but the syllabus wise,
Okay, sir.
because this chapter, SEO syllabus covers a few chapters for a module.
Okay.
Okay,
Okay.
so I am
Okay, sir.
cover all of them to finish one module. There are eight, seven, eight, nine modules, and each contains say two, three chapters. Okay, let me
Yes, sir.
start this again. Yes, follow.
Yes, sir. We will start together, sir. Today no one has joined, sir.
Details are
It's
there.
not good for to continue the
Details are
class,
there.
sir.
If you got the notes, you can find out at least which are you are supposed to know. And definitely, if you have
Yes,
time,
sir. I will.
you don't have to bother with the other subjects. Then you can go more because there is no limit of this particular subject. It can be a
Okay, sir.
full is a syllabus on power plant. So everything is
Okay, sir.
available. Syllabus is giving me a gist. I am also following the syllabus. That's all. Okay. Let us finish and
Okay,
start
sir.
our work.
Okay. Sir, today no one has joined, sir.
Okay, everybody, it is the everyday's pattern. Nobody is there, only one is coming or two is coming, and I'm starting and working over it.
Sir, everyone is busy
Suyata
in
is there
their
now.
routine, sir.
Possibly he was there for a long time. Just 1 second, please. I think it is the practice of every classes for your semester.
So there is a problem in online
Huh?
class, sir. We do not understand clearly, sir.
Which one?
We do not understand, sir, clearly. That's a problem, sir. And sometimes your voice comes doesn't comes clearly, and sometimes it lags, and it is
Just
very difficult to for us to
let
understand.
me open. Then I'm answering your question. Oh my goodness, really I'm in trouble. I don't know how they're behaving like this. I have to results out of the battery. Now, so what I'm saying about the utility stream boiler is almost utility stream boiler is uh, there are the process. Now there are these short by utilities. Utility stream is mostly these are the power plant. These are being used in. Well, what is the utility stream power plant generators? They are used by utilities for utilities like electrical power generation plants. The power which we are using here for in our home, in our college, in our industries, mostly generated by a single or a multiple power plants situated in a state or the neighboring state even. Now, the classification among these three types depends entirely on the application and depends entirely on the amount of steam we are generating and the pressure and temperature which you are maintaining in the steam itself. For this utility type power plant, it is generally depends on whether it is generally operating on the critical pressure below and above the critical pressure. Whether it is operating on below and above the critical pressure, both is available. You know, the critical pressure of steam is around 221, 220, 220, 221 bars. And by the time critical paper pressure is, here we don't have any mixture of, at this temperature, we don't have any mixture of uh, steam or vapor. And due to the different portion of the TS diagram, you have either in liquid state or in gaseous state. Now, we are not, this vapor is not usable in liquid state, so all the critical state mostly we are using in over critical temperature. So there are two definite classification here: subcritical and supercritical. Means the supercritical steam generators are generally are drumless. Means they don't any stock require any stock of required to store the steam for supply, but it directly supply after the steam directly supply the steam to the turbine or other utilities, and it operates more than the critical pressure. That is, critical pressure is 221. It is operationally 240 bars pressure, or even sometimes higher of that. And majority of critical steam generators are 170 to 180 bars, which is comparatively less than the critical pressure, which means we are allowing uh, a certain formation of mixture of water and vapor, because to maintain the temperature of boiler to in very high stage requires lot of energy, and unless you justify the output of the output requirement, your additional cost will not be justified. So we keep it around 100 centigrade centigrade or so for, well, but superheated steam generally we can keep about 540 and 560 depends on the application, and one or two stages of reheating is required. Only one boiler heating is not possible. You have to reheat it again and again to keep it into that extent. That's why you have to generate and confuse different amount of fuel, higher amount of fuel, which will increase your cost itself. Generally, for medium capacities, modern utility plants, we generate steam around say 120 to 100 120 to 2000 kg per hour. 120 120 to 2000 13,000 1300 kg per hour. 120 to 13,000 kg per hour. It's generally it is used in a mega power plant of megawatts around 125 to 1,000 megawatt, 1,300 megawatt power plant. So high requirement of power megawatt or power requirement is generally possible for state-owned or state-owned big power plants itself, where this utility-based power process is used. Here the coal is pulverized in form of the fuel, and if we go for the subcritical steam generators, they generally operate between 130 to 180 bars. Is lower than the critical temperature, more or less producing around 1000 megawatt maximum, and around 100,000 around 1000 to 900 kg per hour of steam generating capacity. But industrial steam generator is like this. A specific industry requires may require a steam generator, which is like industries like sugar, paper, and jute, and so on. Sugar, paper, sugar plant, popular power plants, hospitals, everything requires the application of steam only in the form of steam, not for power itself. Sometimes it's also possible that a particular company is generating his own power for his own benefit, and in that case we have to use this industrial steam generator process. What is the difference between these two processes? These industrial steam generators are mostly smaller in size. They are all like utility steam boilers. They are used pulverized coal and fluidized bed or stoke fire units with coal mostly as a fuel. Generally, only coal is used as a fuel, not any supplement or any substitute of coal like fuel oil is being used here, because capacities requirement is very less. And you have to justify the requirement with your cost input. So no other duplicate or emergency requirement is kept here. Now, sometimes this is also uses the waste heat from some of our industrial plant, and it's sometimes used or termed as waste heat steam generator itself. They operating steam to 50 to 105 bar with steam capacities and up to 125 to 150 kg per second. They don't require superheated steam. They don't require to make it more than 100 or 110 degrees centigrade. They can be supplied in saturated or super saturated or saturated steam. Sometimes even only hot water is being supplied for this use. Next comes the third utility, that is the marine steam generators. Marine, all these ships generally for the powers requires the requires to generate the power during for its running in high seas, and they use boilers for running, making the power requirement to run their propellers and other requirement also can be there in a steam for either vapor or for hot water, etc. They are usually produce superheated steams around 60 to 65 bar and 140 degrees centigrade. It's around less than 100, only 65, say 40, 60, 65 bars. So here you will have, uh, it is much lower than the supercritical temperature. It can be used by simply hot water. It can be used as simply mixture of hot water and moisture, etc. And it is around, it can be as high sometimes, it can be temperature can be produced as 540 degrees centigrade. So it is also sometimes required to be superheated in certain applications. Okay, next let us go for the turbine itself. First of all, there are different turbines, steam turbines, water turbines like this. We are interested to about for the steam plant, so we are interested to know about the steam turbine itself. Now, steam turbine is a prime mover which is constantly convert the energy of high pressure. What is the definition? What do you mean by the term prime mover? In order to generate the power which we are using or generate the electricity we are using, we have to move a certain equipments in a considerable amount of speed and a continuous duration of maintenance of the speed, which is not no way possible to do manually. So we have to use certain methods for running or making the movement or mover to a for generating power. These prime movers are, thus this is the definition of prime movers which are being used to generate the power, which has been where the movement is created by some other artificial means, and this movement is used for generating the power itself by running alternator or power generator, etc. These prime movers are generally all the turbines, like steam turbines and water turbines. Steam turbines, we use high pressure steam for the creation of movement in the turbine, and where water turbine, we use high pressure water for the creation of movement in the water turbine, in the movement in the turbine itself. Now, this type of turbine is prime mover. We have to operate continuously without any breakage, without any stoppage, and without any appreciable reduction of rotational speed, appreciable reduction of RPM itself. How we are doing it? We are using the energy of high pressure and high temperature steam supplied by a steam generator into the shaft work. The steam generator is producing the steam in high pressure, high temperature, and in terms high velocity to uh, generate this shaft rotation of the turbine itself. Now, this energy conversion is generally has two different steps. First, high pressure, high temperature steam first expand in nozzles and carries out at high velocity. There, by the application of different models, will come just after this thing, the divergent or convergent models. You can generate the speed of the increase the speed of the stream by in case of reduction of the pressure of the steam itself. This high velocity of steam coming out from the nozzle itself impinges or forced or targeted or put on a on the turbine blade mounted on wheels itself. Now it is got reflected by an angle, and this reflection is going on, resulting in the rotation of the turbine and suffer a loss of momentum. This loss of momentum of this high velocity stream is converted into gain of momentum of the rotating wheel. Thus, the loss of power in the injected high speed injected stream fluid is required, is used for absorbing the rotation of producing torque. Now, there are steam turbines basically use an assembly of mostly in a nozzle and blades. Blades can be straight, blade can be of curvilinear nature, and it's an important feature of designing a turbine for what will be the exact profile of the blade itself. Sometimes these turbines are used for electrical generations in thermal turbine, and especially in thermal and as well as nuclear power plants. But they are also used to propel large ships in many uh, as a maritime steam generators. Large speeds by providing power for rotation of the steam, I mean the ships uh, for propeller blades, like large ships, ocean liners, and huge load carrying liners, etc., even for submarines and so. So their application is this turbine is there to run the ship. Whatever may the capacity, small, medium, or big, they are used according to that. Here, their capacity is supposed to be increased to run the ship itself. And sometimes we are using them to using the turbine power not to produce electricity by running a generator or alternator, but we run certain observing machines like large compressors, large blowers, and large fans. Mostly, which we have seen, noticed, the large compressors are being run by electricity, but there are instances compressors are directly run by the turbine power itself, and which turbine is directly run by the pressure of the fluid flow itself. This turbine can be condensing and non-condensing, depends on whether the back pressure is below or equal to the atmospheric pressure. If it's after injecting the turbine, injecting and moving the turbine, the steam itself under high velocity is reduced to the low velocity, but high pressure to low pressure, but temperature remains same. And it may so happen the pressure of which is reduced is above the atmospheric pressure. It can be equal to the atmospheric pressure. It can be less than the atmospheric pressure itself. Now, there are, I don't have any time, I think. It is nearly finished. I'll start it day after tomorrow and finish this turbine portion. I lost a lot of time. Okay. So far, this is the class today. Thanks for coming and patient hearing. And Nitish, Nishant, if you have any queries, just send me in the WhatsApp group and I will answer. ठीक है? Goodbye.